Sample problem 7.09. Figure shows a constant forces F1 vector and F2 vector acting on a box as the box slides rightward across the frictionless floor. The force F1 vector is horizontal with a magnitude 2 Newton and force F2 vector is angled upward by 60 degree to the floor and has magnitude 4 Newton. The speed v of the box at a certain instant is 3 meters per second. What is the power due to each forces acting on the box at that instant? And what is the net power? And then we have to answer, is the net power changing at that instant? So here we have to answer for these three questions. The first question, we have to find what is the power due to each force. So how many forces acting on this box? We have two forces, which is F1 and F2. And then once we find the power for F1 and F2, we have to find the answer for net power. And then based on the answer, what we are going to get for net power, then we have to answer for the third question. Clear? So first of all, let's write the given and then let's see what is given in the figure. So in this question, they give two information, the magnitude of the first force, which is 2 Newton, and then the magnitude of the second force, which is 4 Newton. And also they mention the speed on this box is 3 meters per second. And let's see the figure. So the same information was given in this figure. So you can see the figure, a box which is kept on the frictionless horizontal surface, and we applied two forces, F1 which takes the value of 2 Newton and F2 which takes the value of 4 Newton. But here F1 is the horizontal force, F2 is the angle force, which is 60 degree, and then the speed of the box, which is in the rightward direction of 3 meters per second. So what they ask, we have to find what is the power for F1 and F2. So let's apply the rule. What is the rule? In theory, we studied the formula for power P, which is equal to FV cosine theta. So we have to apply this rule for F1 and F2, and also the speed V is given here as 3 meters per second. So let's find the answer for P1. So the answer for P1, which is given by the rule P1, which is equal to F1V cosine of theta 1. So why I just mentioned the number for the theta, because we have to find the answer for the power for F1 and F2. So that's the reason I gave for P1 the angle is theta 1. For P2 I'm going to use the angle theta 2. Clear? So now I'm going to substitute the value in this formula. What is F1 magnitude, which is 2 Newton, multiplied by, and the speed of the box, which is 3 meters per second, multiplied by, now the theta 1 is very, very important. You can see the figure. We applied the force F1, which will be in the leftward direction, but the speed which will be in the rightward direction. So the angle between F1 and V, which is 180 degree. That means the theta 1 takes the value of 180 degree. So cosine of 180, which takes the value of -1. So now we got the answer here is 2 multiplied by 3 multiplied by -1, which is -6 watt. That is the answer for P1. So this is the force, this is the power acting on the box for F1. The power due to F1. Likewise, we have to find the answer for P2. Again, the same rule. So P2, which is equal to F2 multiplied by V multiplied by cosine of theta 2. Here F2 is the angle force, which is 60 degree. So the information is already given directly here. So theta 2, we have to use the angle for 60 degree here. Now I have to substitute the value. So here we have F2 magnitude is 4 Newton multiplied by the speed is 3 meters per second, and cosine of 60 degree is half, which is 0.5. So I have to multiply by 0.5. So 4 multiplied by 3 is 12, and 12 multiplied by half, which is 6 watt. So the answer for P2 is 6 watt, positive of 6 watt. So P2 value also we got, which is plus 6 watt. Now what we have to do, we have to find the answer for net power. So how to find the answer for the net power? The answer for the net power, which is P net, which is equal to P1 plus P2. So here the value for P1 is -6 watt and P2 value is plus 6 watt. So what is the answer? The answer here for the net power is 0. Why? Minus 6 and plus 6 will give the answer 0 watt. So this is the answer for the net power. Clear? Now we have to answer for the third question. What is given in the question? Is the net power changing at that instant? So how can we give the answer? We have to see the answer for the net power. So what is given here? The net power, which is equal to 0 watt. So in this, what we are going to learn, the kinetic energy is not changing. So that means the speed remains here is 3 meter per second. So P1 and P2 is constant. So our net power will not be changed. So your net power, which is constant. Clear? So what is given? Let's see the question more. So is the net power changing at this? So it will not change. It is a constant. Why? Because we got the answer here as a 0 watt. So the answer for the third question, the net power will not be changed. It is a constant. Constant. Okay. So we have to give the answer like this. Clear? This is the answer for this question. Thank you.